Friends, we'll be doing an experiment to show heat transfer through conduction, for which we have taken a candle, a spirit lamp, and a few iron nails and a metal scale. So with the help of the candle and some molten wax, we will be attaching the nails to the iron scale, and for that we are putting some drops of molten wax and fixing the nails on the scale, and we are doing it one after another at some distance from each other. So here we have 3 nails fixed to the scale. Now we will heat one end of the scale using our spirit lamp, and what we are trying to show that conduction is a process through which heat gets transferred from one end of an object to slowly inside through particles. So heat is passed on or given from one particle to another and slowly passes inside an object. So this is what we call as conduction of heat, which we will readily see. So the spirit lamp is now burning, and now we will put only one end of the scale in the flame. So only the end gets heated, but the heat that the end gets starts getting passed on inside the scale towards the other end, and slowly, as we see, as heat goes further, the wax melts and the nails drop down. 2 nails have already dropped down, and still the heat is carrying on, and now the third one has gotten dropped. So we saw how heat got transmitted inside the scale slowly from one end to the other end, and this is a phenomenon we often see in our kitchen when we are working with steel utensils or big spoons, etc. So here's another very interesting experiment. We have 2 balloons, one full of air, and the blue one is full of water. It is half water and half air, and the red one is full of air. Now we will bring these balloons on top of a flame of the spirit lamp, and we will see what happens. So here's our flame, and we bring the red balloon near the flame and make it touch the flame. The moment it touches, the balloon bursts with a loud bang, and now we will see the effect on the blue balloon. In fact, the bang was so loud and so much air came out that spirit lamp got extinguished. So we have lighted it again, and now we bring the blue balloon. So the blue balloon is comfortably sitting on the flame. In spite of the fact that rubber is extremely delicate, it cannot tolerate heat and gets burst easily, here it is comfortably sitting on a flame and not bursting. So what's happening? So this is because of the conduction of heat. The flame is heating the rubber, but much of this heat is being transmitted or conducted away to the water inside, because of which the rubber doesn't get heated enough. So it doesn't get very hot and therefore doesn't burn. And if you want, you can actually boil this water inside a balloon. The same experiment we can do with a paper cup as well. You can actually heat water in a paper cup, keeping it on a flame because of the heat getting conducted away. So now we have seen conduction as one mode of heat transfer. Now we will go to other modes of transfer, that is convection. Convection of heat, which is done in liquids or gases, or let's say fluids. So here we will be using, first, to see convection currents, we will use potassium permanganate, a spirit lamp, and to put the potassium permanganate inside water, we will be using a straw, through which just one particle, one crystal of potassium permanganate is put inside water, but we will put it through the straw so that it doesn't dissolve on the way and go straight below. So now we have put in one crystal inside. It has reached down below the beaker, and now it is lying below, already started dissolving, but now we will give some heat to this water through our spirit lamp. So the water has started getting heated, and immediately we see a ribbon of colored water rising up. So the hot water actually expands, gets lighter in weight and rises up, and from the top colder water sinks below. So what we have now is what are called as convection currents, which means hot fluid rises above and colder fluid comes down below, and a cycle is set up or a circle is set up. So water will continuously rise up as it gets more heat. So what we are seeing is convection currents. So this is unlike conduction. In conduction, heat is given from particle to particle to particle. Here, the particles themselves are moving from one place to another, from below to top, carrying heat away with them. So this is another mode of heat transfer which is not seen in solids but only in liquids or gases. So we can see much of the water has become colored, which means the heat has now spread throughout the liquid. Here we have taken a round paper and cut out a spiral shape using scissors and hung it with a thread in the middle, so that we have a snake-like spiral shape of paper, which now we will put over a candle flame, and we'll see what happens. So first we'll light our candle. And bring the paper spiral above the flame, and it immediately starts rotating. That's because of convection currents. Hot air is rising above. Hot air, which gets lighter in weight, rises above, and it makes this spiral go round and round. Though there is a little danger here of burning the paper if it touches the flame, still it's a beautiful experiment to see convection currents in air which we cannot see otherwise. So isn't it interesting seeing how air rises above through convection currents? The third mode of heat transfer is radiation, or heat coming as rays. We will be using sun rays, and we will be using a prism to put sun rays, to bring it to the prism, and those rays, the white light, will be split in its 7 colors using the prism. If we tilt the prism at the right angle, correct angle, the light splits up into the 7 colors of a rainbow, starting from violet, blue, going up to orange and red, and we get a nice spectrum on the ground. So we'll have to now fix this prism in such a way so that the spectrum remains stable here. What we will be trying to check is if the heat which is coming with white light through the sun, from the sun, if the heat is same in the blue region of the spectrum and the red region. So here we are using 2 digital thermometers and the metallic sticks are their sensors. So one sensor is kept at the blue region, the other is kept next to red, actually even beyond red, a little away from red, and the prism has been balanced in such a way so that it is tilted sufficiently to give a good rainbow on the ground. And now we will see the effect on the two thermometers, the digital thermometers, which will show us the reading on their scales. So let us see what is the temperature we get in the blue region and what is the temperature beyond the red region. We see at present that in the blue region the temperature is 37.9 degrees centigrade, whereas in the red region or beyond red it has already become 38.8. So on the red side the temperature is higher. We are getting a difference in temperature between the two thermometers, and this is a very surprising finding, that heat is coming with all colors of the white light, but it is not same. Some colors are getting more heat, and actually speaking, the maximum heat is not even in the red color but beyond red, after the red color, and we know those rays as infrared rays, which our eyes cannot see. Actually, the sun's light or the sun's spectrum doesn't contain only white visible light, but a lot of rays which are on both sides of the visible spectrum, which is one side of the blue and on the other side beyond red. And many hundreds of years back, William Hershel was a scientist who did a similar experiment to detect maximum heat just next to red in a region which is called the infrared region, where we cannot see light with our eyes, but we can detect a lot of heat, the maximum amount of heat which is carried in the infrared region. So heat is carried through radiation exactly the way light is carried. So this is heat conduction, or rather heat transmission through radiation, which is the third mode of heat transfer, and there is no difference between light and heat here.